6.13, what do we got here? If a single length of a conductor has 2 ampacities, the lower ampacity is to be used for the entire circuit. You're like, what the heck is that about? Well, this is 310.15a2, and that's what the rule says. Where more than one ampacity rating applies to a single conductor length, the lower ampacity must be used for the entire length. Here we go. We have a raceway on the roof. Let's say the ambient temperature is 90 degrees Fahrenheit. Since it's on the roof, I have to add 60 degrees Fahrenheit as an adder. And that was 310.15b2a is the adjustment factor by going to the adder at 310.15b3c, add that together. And if I add those together, that gives me a multiplying factor for temperature of 0.58. If I ran 12-gauge wire on the roof, that wire is rated 30 amperes if it's a -2 wire, 90 degrees C. So you take the 30-ampere conductor times the 0.58 temperature correction factor. It's 17.4 amp wire. But watch this. It's only 17.4 amp wire up on the roof. Once you get around the roof, we no longer have that temperature adjustment factor, so it would be a lower ampacity. So it's 30 amps on the side of the building that's not being exposed to the sun, but yet it's 17 amps on the top of the roof of the building. So now we have is where more than one ampacity applies, 17.4 plus 30, the lower of the ampacities have to be used. Now there's an exception. 310.15a2 exception. Please do me a favor. Put it on pause. Get your code book. Take a look at the basic rule about when you have multiple ampacities on a conductor length. Then take a look at this exception. Okay? So just, be right there with us. Don't just let it go by and think I'll get to it later on. Just stop it right now. All right, let's go to it. The exception says this. The higher ampacity can be used if the length of the lower ampacity isn't more than 10 feet and it isn't longer than 10% of the higher ampacity length. Let me go to this graphic here. If you have an 8-gauge wire at 90 degrees C rated 55 amperes, but because we were on a rooftop, let's say right here, using this 8-gauge wire right here, that it has a temperature adjustment factor, correction factor, 0.58. That was your 90 degrees Fahrenheit and your 60 degrees Fahrenheit added, 150 degrees Fahrenheit. Table 310.15b2a, 0.58 of 58 amperes, 55 ampere wire at 90 degrees C. This wire is 31.9 amperes. So go back over here. This is 31.9 amp wire. This wire is 55 amp wire. What this exception says is that you can use the 55 ampere wire for the entire circuit if the length of the lower ampacity isn't more than 10 feet. If the lower ampacity in this example here is 5 feet, and the length of the higher ampacity is 55, as long as the lower ampacity doesn't exceed 10 feet and doesn't exceed 10% of the higher length, the higher ampacity length is 55 feet, so since this is 5 feet, it didn't exceed 10% of this, then in this case here, I could use 55 amps for the entire circuit. Michael?
It's not a lower ampacity wire, it's a lower ampacity rating. The wire stays the same.
However, you might be right. I don't even know what I said. Let me say it again. The ampacity of this portion of the wire is going to be a lower ampacity than this portion of the wire.
Right.
If that makes it better.
But they're all the same size.
So it's the same wire.
Well, it's the same 8-gauge wire.
Right.
It's just that we have two different ampacities for that circuit because we have two different conditions of use. And if the condition of use is where the lower ampacity is going to always be used for the entire circuit. That's a basic rule. But there's a condition that if the lower ampacity is not more than 10 feet long, it doesn't exceed 10% of the length of the higher ampacity, then we can use the higher ampacity for the entire length. I don't know if that makes it any better. Okay? That's used a lot for people up on the rooftops.
Mike, can we go back a couple slides to 151 there?
Okay, this slide right here.
And I was asking John about this, and we've got the lower ampacity on the roof, and I don't know how many times I've had this question asked to me, where we have the 12 THWN-2 equals 17.4 amps, 30 amps times 0.58. And most everybody that I, in this group would probably say for the overcurrent protection device, it would be 20 amps. And I have to say, I always tell my guys, to me, I think it would be 15 amps.
Okay, let's work at it this way. I want to answer this question assuming it's not a photovoltaic system. Because when it's photovoltaic systems, we got a whole different set of rules in Article 690, which we are going to cover on this DVD. Let's just simply talk about that this wasn't supplying any kind of array on the roof, but we just simply have a 12-gauge wire on the roof, and it had an ambient temperature of, the multipliers, and we have a 17.4 amp wire. The rule is this, 240.4 tells us this. You have to provide overcurrent protection of conductors at its ampacity, except that it's permitted as A through G or something like that. And then we go to B. 240.4b says, well, if the ampacity, 17.4, doesn't correspond to the standard size, then you can go up to the next standard size overcurrent device, which would be what size?
It would be 20 amps.
Be a 20 amp breaker. And then we got to go to 240.4d that says what's the maximum overcurrent protection you can put on a 12-gauge wire, because we got to make sure we check the small conductor size. And 240.4d says on a 12-gauge wire, what's the largest overcurrent protection?
20 amps.
20 amps. So we're okay there. However, you can only go to next size overcurrent device as long as you meet the conditions of 240.4b, and that's that you're not supplying receptacles.
Okay.
Because if you supply receptacles, there's no way to control the load. But if you're supplying loads and you have a 17.4 amp wire, you put a 20 amp breaker. But I know, Eric, and you were thinking this, if you're not going to say this, you're thinking, well, wait a minute now. That's assuming that the ampacity of that wire is capable of carrying the load.
Right.
So we always have that assumption on the side. Okay, the wire carries the load at 17.4 amps. What size overcurrent protection? Well, 20 amp breaker would be on that there. Could you put a 15 amp protection device? Sure, but then you got to be sure that the load is not going to exceed the rating of the overcurrent device.
Right.
Because now on a continuous load, you limit it to 80% of that 15 amp breaker as opposed to 80% of the 20 amp breaker.
Well, and that's what I always get, that, they always go, well, then why am I even doing this? Because if it's limited to 17.4, but I put a 20 amp breaker on it, is there a potential of that conductor going up over 17.4 amps? And I always say, yes, there is, but you got to remember, I mean, this is what we have to work with, and we got to limit that ampacity on that conductor.
But see, here's the deal. We have to answer this simply in a code concept. If you have a 17.4 amp wire, are you permitted to put a 20 amp breaker on that if you comply with the conditions of 240.4b?
Yes.
Yes.
Then I stop the conversation with people. Because the more we talk about something, the more we can make it more complicated. Well, you could exceed it. You start going into all these other scenarios.
Right.
Listen, I don't write the code. I'm just a messenger here. I need to have a wire that's protected at its ampacity according to 244B. I got that taken care of. I got to make sure that the wire is sized to carry the continuous load, right? That was your 125%. Got to make sure the overcurrent device is sized for the continuous load. As long as I meet all of those rules, then I met the code and the safety requirements, and I'm not going to get in there and start. Now, if you're not taking a test, hey, put a 15 amp breaker on there if you want to. You know what I mean? But you got to be careful. When you're taking a test, you got to answer exactly what the code is. When you're designing an installation, it's a totally different ballgame. So we got to be careful that we understand code. Just code. The answer is yes. Did I answer your question there?
Thanks.
Just code-wise, 20 amp breaker, we're fine. We're starting to tie in some of these other rules